Hi everyone, welcome back to the session. In the last session, we discussed about total internal reflection. In this session, we will look at few real-life examples and practical applications of total internal reflection. Let's get started. See, you might have noticed during summer days when the sun is scorching hot, right? If you're walking down a roadway, sometimes there appears to be a puddle of water at a distance, right? Now if you go to that place, it just disappears, but it appears to be at a further distance. Again, if you go to that place, it just disappears, and again it appears to be at even further away from you. So this is an optical illusion. So this is called mirage. So this is an example of total internal reflection. Okay, so you can see here people are walking on the ground, so there appears to be water flowing on the road, but actually there is no water, it's just an illusion, right? So mirage is an example of total internal reflection. Now the same effect can be observed in deserts. You might have heard people getting lost in the deserts due to this illusion. Let's understand why this happens. See, when the sunlight falls on the ground, right, it heats up the ground and its temperature increases. Now the air layer, which is closer to the ground, absorbs this heat energy and becomes hot, right? Its temperature also increases. Now we know that as the temperature of the gas increases, its density decreases, that is, it becomes rarer. Now as you go up, the temperature goes on decreasing, which means the density of the air layers goes on increasing, right? So you can see that here. So near the ground it is hot air, and above it is warm air, and if you go up, it is cool air. Now a ray of light, right, which is coming from a tall object, maybe a tree or a camel or even a cloud, right? So as it comes down, it passes through continuously decreasing layers of air density. So as a result, it undergoes continuous refraction by bending away from the normal. Now at a particular layer or at a particular point, if the angle of incidence is greater than the critical angle, it undergoes total internal reflection and it reverses its direction and goes up. Now, when this light ray hits the observer, right? The observer, the eye, perceives this light ray to be traveling in a straight line, and the image is formed here, right? It sees the tree or the camel or the clouds here. Now our brain interprets this as if it's a reflection from a puddle of water. So this is the reason for formation of mirage, right? It's because of total internal reflection. Now let's look at applications of total internal reflection. One of the most important applications of total internal reflection is optical fibers, which has revolutionized our communication system. Compared to traditional way of transmitting data using copper cables, optical fibers are way more efficient and they can transmit large amount of data in a blink of an eye, and practically there is no loss of energy at all. So that's why optical fibers are preferred over copper wires in many situations. And also, in metro cities, any individual can have a high-speed internet like 500 Mbps, 1 Gbps, right? So all this is possible because of optical fibers. Now let's see how this optical fibers work. So you can transmit information in the form of light pulse or light rays in the optical fibers. So how this works is, the idea is that you can trap a pulse of light or a beam of light inside a transparent medium. For example, as you can see here, a light ray which enters the tube here undergoes multiple reflection within the tube. It gets trapped within the tube. So once it enters one end of the tube, it can only come out from the other end. So it gets trapped within the tube. Now you can see the schematic diagram here. So the central portion, which is a transparent medium, is called the core, and it is surrounded by a rarer medium which is called cladding, and there is a third layer which is protective layer. So when the light beam enters this optical fiber or a transparent tube, because it is surrounded by a rarer medium, it will undergo total internal reflection multiple times within the tube, and it can come out from the other end. So this is the idea behind transmitting data or information in the form of light with the help of optical fibers. Now we can see this in action. Observe the light traveling in the glass here. You can see that the light is actually pointed at an angle at this face, right? But you can clearly see that the light is actually coming from the other end of the tube. And also, if you observe the inside, you can see that the light is getting total internally reflected multiple times here. It is actually trapped within this tube. In the same way, here you have an actual optical fiber here. See that the wire, right, or the fiber or the tube, glass tube, is randomly thrown here, right? It is curled. Now, light, we know that light travels in a straight line. Do you think the light will come out from the other end? Let's see what happens. You can see, once the light is pointed to this face, it can come out from the other end as well. We can use this in endoscopy, right? Doctors can actually pass this through the alimentary canal and take images of our internal organs.